We'll just start over.
Well, we could
This
start
is
over
Geometry,
and-
Chapter 15, Lesson 4 on page 640. We're talking about the candy bars. All right, now remind me, it's the Three Musketeers, Snickers, Butterfingers, Milky Way. Okay, we decided which was our favorite. Did anybody choose Three Musketeers as their favorite? No. Yeah, I don't think, I always have those left over when I bring them. Probably the most dense candy bar, well, we're deciding between Snickers and Butterfinger. So it's undecided. All right, but what you're looking at, those images show you a cross section of that candy bar. And a cross section is the intersection of a plane with a solid, where it literally cuts it in half. So the knife the knife would have been the plane used to cut it. Now looking at those cross sections, which cross section do you think has the largest area?
Three Musketeers.
You think the Three Musketeers?
Probably.
Yeah. Which one would have the smallest area? The Butterfinger. Right. So thinking of the volume of one of the small bars or a regular size bar, which one would have had the largest volume? What is volume?
Length times width times.
So I'd
Length
say
times width times height. It's the
probably-
space it takes up.
So probably the Three Musketeers.
If
Three
if
Musketeers.
that's right, if the cross section of the Three Musketeers has the greatest area, then and assuming all the bars are the same length, then the Three Musketeers is going to have the greatest volume. Make sense?
Yeah.
Does that make sense? All right, we talked about prisms in the last class. Somebody remind me what makes a solid a prism. You looking at your book? What makes a solid a prism? Do y'all remember? It's 3 dimensions.
Lateral face.
Lateral faces are what shape?
Like rectangle.
Geometric shape.
They're geometric. They're what?
Polygon.
Specific types of polygons.
They are
Regular polygons.
congruent.
They're not necessarily regular.
They're quadrilaterals.
They are, but what type of quadrilaterals? Starts with a P. Parallelograms. The lateral faces of a prism are parallelograms. All right? And their bases are, what's unique about their bases?
They're congruent.
They're congruent. Yes. So we have 2 congruent bases. They could be anything from a triangle to an octagon. Doesn't matter. But all the lateral faces between the bases are parallelograms. All right? Now, are all parallelograms just straight up and down? No. Remember we talked about some of them are like the Leaning Tower of Pisa? Or if you look on page 643, you see the image of the green coins, page 643. Maybe they're blocks. You see the green image? Everybody with me, page 643. See, you see the green image? The image of the green blocks or green coins? All right, are there the same number of blocks in each pile? Somebody count the right one, somebody count the oblique one. The number of blocks in the oblique. You got the right one? Somebody else confirm. Somebody else has the oblique.
Yeah, no oblique.
All right, Jack, how many are in the right one?
13.
13. How many are in the oblique?
13.
13.
Wait. You don't mean the right one, like looking at the right one.
Correct. I meant the right one as the one that forms a right angle, standing straight up.
Oh, I did not know that. I was counting.
That was not.
Oh yeah, me too.
Stop.
they both have 13 in them?
Yeah.
Yes. Are the shapes of the blocks the same?
No.
The green things.
Page 6.
The shapes
Oh,
of the
shape
blocks
block,
on
yeah.
it.
The shapes of each block is the same. All right? If you just look at that image and we did a cross section at any point, would their cross sections look the same?
Yes.
Yes, because every image it looks the same, right? So, do you think the volume of both of those stacks is the same?
Yes.
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 Because has the height changed?
No.
Okay, how do you measure the height on the image on the left?
The altitude?
Yes. What is the altitude?
It's like it's the vertice to like a makes a right angle. I don't know how to do it.
Okay, what is an altitude? By definition, an altitude is a line that's perpendicular to both bases. So, where would the altitude go in, do you think, the image on the left? Straight down the middle. That's exactly what I think. Straight down the middle. All right. What about the image on the right? Where would the altitude go?
Like from the corner down.
Yes. Yes. So, I'm just going to do this. So the one on the left, it would have been like that, right? But the one on the right would have been like this. Make sense? But their altitudes are the same. So do they have the same volume, even though they look different?
Yes.
All right, so then how can we know two solids have the same volume?
If they have equal bases and heights. And altitude.
If the area of the base of their bases is the same and they have the same altitude, do they have to have the exact same shape? In that case, they have the exact same shape. Can one be triangular and one be circular? And can they have the same volume?
Yep.
As long as what? The area of the bases is the same and their altitude is the same. That is correct. So volume is literally the space that object takes up. Does that make sense? Sort of like if I had a cup of water and I put one of the candy bars in it, what would happen to the level of the water? It would go up by what?
The same amount like anymore.
The same, what do you mean amount? The same volume of the candy bar. That's correct. The water would be displaced by the volume of the candy bar, right? All right, so volume is the area of any base. It doesn't matter the shape of the base. Volume is the area of the base times its height. It could be a circle. And what's the area of a circle? Pi r squared. It could be an octagon. And what's the area of an octagon?
One of the sides.
And times the radius. No, Mr. Square.
Mr. Squared. What does M stand for?
That'd be credit with credit.
Like something with like sin and
It is something like that, but it's going to be on your test. So it's N times
180 over.
the sine,
Of 180 over number.
180 over N times cosine.
yeah.
180 over N, right? Okay. What if it were a triangle?
I'm sorry.
Based on, yeah, 1/2 base.
Could I use Mr. Squared if it were a triangle?
Yeah.
You know.
No.
100% of the time
Yes,
you
you
could.
could.
Yes, I could.
But that's not like cosine over like 180 over 3. Like
180 over 3, 180 over 3, 3, and then times the radius squared. You'd have to know the radius squared. Right? You could. Okay, what if the base were a square? What's the area of the base?
Side times side.
Side squared. What if it's a rectangle? What? Yes. Length times width. Yes. What if it's a parallelogram?
oh wait, base and altitude.
Base times altitude, we'll call it height. What is the altitude? Is it the other length of the side of a parallelogram?
No.
It is not. That is correct. Think of a parallelogram. This is the base. The height is perpendicular to both sides. This is not the height. Not the height. Got it? Now, if we had a square prism and I took a cross section of the square prism, what would be the shape of the cross section that I see? Square. If I had a rectangular prism and I took a cross section of the rectangular prism, what would be the shape that I see? What?
A rectangle.
Or a rectangle.
Are you cutting it long?
What does cross section mean?
And you cut it in half.
And half.
So that
Or
it is
along any of its planes.
So it could be
Well,
a
depends on
rectangle or a square.
Define. You
Yeah,
can
it
define
depends on
curve.
what the
On the
rectangle.
quadrilateral.
You have to
Oh, on
define
any of
the
its
size.
parallel planes.
Define side.
Yes, it would be a rectangle. Ladies and gentlemen, it would be a rectangle. What if I took a cross section of a triangle? What would that cross section look like?
A right
It would
triangle.
probably look
It would just look like a triangle. It depends. If the solid's a right triangle, the bases are a right triangle,
Oh yeah.
right? When we're talking prisms, these are the bases. You got it? When we're talking cross section, you're cutting the parallelograms.
you totally agree.
Make sense? All right. All right. So volume is whatever the area of the base is, depending on the shape, times its height, its altitude, which is a perpendicular line between both of the bases. All right. Now, there's Cavalieri's principle. All right. Maybe I should just write this on the board. I do not like the way the book explains this at all. I think it's just, I don't know. I just don't like it. There we go. All right. So here's Cavalieri's principle. I'm just going to write it on the board. I'm going to write the definition that I wrote. Cavalieri's principle.
13.
With capital.
It's what we just talked about, all right? If two solids have the same height, if two solids have the same height and same cross sectional area at every level. That's area at every level. That means it doesn't change shapes in the middle of the solid, right? They have the same volume. So it's very unlikely that those four candy bars have the same volume because their cross sections all look different. Maybe the Milky Way is close to the Snickers bar, but definitely the Three Musketeers and the Butterfinger is different. All right, so Cavallari just says if we have two solids, they have the exact same altitude, and where there's a cross section at every cross section that we can divide it into, if those cross sections have the same area, then those two solids have the same volume. That's all Cavallari's principle says. All right? Does that make sense?
If they have same base, same height. Or
No. If they have the same height and same cross-sectional area, so that's not the same cross-sectional shape. They can have different shapes.
Yeah, I mean like same, like their areas.
But the area of every cross-section, yes, at every intersection of the plane with that solid is the same. It's much like the image below Cavallari's principle. One is a rectangular prism, one is a triangular prism. If we look at their cross sections and the area of that rectangle is equal to the area of the triangle and they have the same height, then they have the same volume. Yes.
What determines how far apart planes are from each other?
You have to be able to intersect it at any place in the prism. So, it has to be at the prism has to have the same shape throughout.
But just in general.
It doesn't matter.
For any solid, the planes like.
It doesn't matter how far apart the planes are. Yeah.
Okay.
Could there be like all the way right on top of each other?
Could there be what?
Like almost right on top of each other?
They could be. Yes. They could be. Yes. Because you think about the stack of blocks. It could have just been after the first block we did the cross section of the green blocks. You remember? All right, now I gave you a handout.
I think I had one at one point.
There it is. Okay. Now we're going to look at 4 and 5. All right. In number 4, we have 2 cylinders. A is more like a Coke can, right? B is more like, I don't know, leaning tower. Yes, a squashed can. I don't know. All right. But they're both they're called cylinders when the bases are circles. They're not called prisms. Can we find the volume of the cylinder B? What would be the volume of cylinder B? And would A be the same?
Would be
110.
What's the volume of cylinder B?
110.
it's
110?
No, I would.
it's 25 times 22.
It's 25 times 22, so whatever.
Okay, give me the whole formula. Volume equals
I think so, Jack.
Volume.
equals
Base to base.
pi 5 squared.
It's a lot.
That's the area of the base, right?
So we're not
Times the height, 22. What do you get in your calculators with that? Leave pi is pi, ladies and gentlemen. Leave pi is pi. Your calculator will leave pi is pi. Yes.
5
Wait, how do I
squared.
leave pi on my calculator?
You use pi.
You use
pi
Shift
button.
X10.
Yours is pi button?
Syntax
There
error.
is.
Wait.
5
What do we
squared
enter?
times 22.
Pi times 5 squared
550
times
pi.
22.
It's 550 pi.
550 pi.
Wait, Wait, 5 times pi squared.
No. Pi times 5 squared times 22. Pi times 5 squared times 22.
But it'll give syntax error if you do it in that order.
Mine's breaking.
You got to go put a times between pi and 5 squared.
550 pi.
Go put a multiplication sign between your pi.
Pi times
Yes.
5
I got.
squared
Did you get it?
times 26.
550? Okay, do you believe
50 pi
550 pi inches cubed? Why is it inches cubed?
cubed because it's volume.
3D.
It's 3 dimensions. That is correct. All right? Yes? Okay, I'll fix it in a minute when we break. All right, look at number 5. It says that this right triangular prism and the right rectangular prism, they have the same volume. If the center plane intersects the solids parallel to their bases, which of the following choices could be the base and height of the triangular cross section? Okay, so help me think through that. Okay, keep thinking. And how do I figure that out? Okay, Luke and Jack think they know it. Keep thinking. Everybody keep thinking. And how are you figuring that out? So I want you to be able to reason your solution, not just give the solution. Author, do you have it? All right, somebody explain what the question's asking. Jack, explain what the question is asking.
It's asking for the area of the base, basically, which is equal to 48. And the area of the triangle goes on that base times height. Since it goes to base and height, we're going to multiply 48 times 2, so that base times height is equal to 48 times 2, which is 96. And then the only multiples of 96 are 8 and 12, so these are like 8 and 5.
Luke, is that what you thought? 8 and 12?
I thought 4 and 12, but I forgot about the half base times height thing.
Correct. So for the rectangular prism, the area is 8 times 6. That has to equal the area of the triangle, which is 1/2 base times height. You following that so far? Has to equal that.
Wait, so is it 8? And the height equals 8 and the base equals 12?
Yes.
Okay.
So how do we solve this? We multiply by 2 on both sides. That's 48, so that's 96 equals the base times the height. So you have to look at the options where the base times the height equals 96. All right, let's